Hey everyone, and welcome back to another two-dimensional kinematics problem, adding and subtracting vectors. So just like the previous video, this one also refers to vectors given in video number 35. Okay, so for the vectors shown in video 35, determine A, B minus 2A, and B, 2A minus 3B plus 2C. Okay, so if you didn't see video 35 or you don't remember, here it is once again. Okay, so here's the graph that we're dealing with. You've got your Cartesian plane, you've got your vector A with magnitude 44, your vector B with magnitude 26.5, and your vector C with magnitude 31.0. Now, in order to not draw this once again, I'm just going to simply write down the components AX, AY, CX, CY, BX, BY that we had developed in this question. If you are not sure how to calculate these components, just go back quickly to video 35 where I go through briefly how to calculate these parts of the triangle, and then you can come back to this. Okay, so without further ado, let's get into it. Okay, so for A, following in the same color coordination, let's write down our values just so we have them. AX we found to be 38.9. AY we found to be 20.7. BX we found to be negative 14.8, and BY we found to be 22.0, and CX we found to be 0.00, CY minus 31.0. Okay, so those are the numbers from the earlier question. Now we can actually dive in and start this one. So specifically for part A, we are tasked to find, so it actually officially starts here. We need to find B minus 2A. Now, just like in the previous problems, you're taking a vector and you're subtracting double another vector. A vector minus a vector is a vector. Okay, so your answer is going to have three components, an X, a Y, and a Z component. So the way I'm going to break this down is the following. B has an X and a Y component. So instead of writing B like this, I'm going to write it as BX, comma, BY. A also has two components, but there's a 2 in front, so we don't want to forget about that. So minus 2 bracket AX, comma, AY. And if you remember from before, the BX's goes with the AX's, the BY's go with the AY's. X's with X's, Y's with Y's, right? You don't want to mix apples and oranges together. So if we actually want to write this as one vector, right, because technically whatever this is a vector that's going to have an X component and a Y component. The X component is simply BX minus 2AX, and the Y component is BY minus 2AY. Now, personally, I like solving it like this because it really breaks down how to solve it and really helps you understand how to do it. Because at this point, it's simply a matter of plugging in the values. Okay, so BX is minus 14.8. You just have to be careful with your negative signs. Minus 2 times AX. AX is 38.9. That's for the X value. For the Y value, we've got BY, 22.0, minus 2 times AY, which is 20.7. Okay, so we close that bracket off. So essentially what you're getting is the value of B minus 2A, and that is going to be negative 92.6 for the X and negative 19.4 for the Y. Okay, so we're asked to determine B minus 2A. So it's great, we found the coordinates, but we're going to actually find the magnitude and the direction of this vector. Okay, so it's not sufficient to simply express it by this. Okay, so let's go ahead and do that. So we'll find the magnitude first. Okay, so the magnitude, remember, it's like Pythagorean theorem. You take your B minus 2A, whatever it is you're calculating, you put two vertical lines, one on each side, and that's going to be equal to the sum of the squares of these two components, and then you take the square root of the entire expression. So that's going to be minus 92.6 squared plus negative 19.4 squared. Okay? And when you calculate that all out, you're going to get 94.6. So there's the magnitude of b minus 2a. Okay. We're going to have to go and do the angle for this as well. I'm going to do that on a separate sheet. So we've got the magnitude, 94.6. Let's keep going. For the direction, we want to draw a picture, as always. Okay, so let's go ahead and do our graph. You can see the x is negative 92.6, the y is negative 19.4. So you can estimate this is going to be in the third quadrant. Okay, so I'm actually just going to go ahead and draw it like this since I know what quadrant it's going to be in. So x, negative 92.6. Let's say we go like this. So there's our negative 92.6. And now we go down negative 19.4. Okay. And we're going to go ahead and connect that. We're going to draw our resultant. Remember, from the tail of the first vector to the tip of the second, in that order. So there's your resultant. Here's our angle theta. Okay. Now let's calculate what theta is. So tan theta is equal to opposite. This value, the side of this right angle triangle, is 19.4. And remember, like I mentioned in the previous video, I'm not putting the signs in. I can always determine that later. So 19.4 divided by 92.6, you're going to end up getting, let's do this. Theta is equal to, let me grab my calculator. Inverse tangent of 19.4 divided by 92.6. 11.8 degrees. And sure enough, that is the angle, right? That looks like a small angle anyways. Okay, so this is 11.8 degrees below the negative x-axis. So therefore, when we quote our answer, we're going to say, therefore, b minus 2a is equal to 94.6, that was our magnitude, remember? And in square brackets, we put our direction, 11.8 degrees below negative x-axis. Okay, so there it is. There is part A done. So just to recap, you've got your component. You find the component of each vector, the x and y components, if you're dealing with two dimensions, and you simply take the expression and you simplify it, right? So if you have b minus 2a, express b in terms of its components, express a in terms of its components, and then simply try to make an expression where you have just one vector as your answer, something for the x and then something for the y. So let's go ahead and answer part B then. 2a minus 3b plus 2c. Okay, so let's go ahead and do that right here. So for B, 2a minus 3b plus 2c. Same strategy I used before. Okay, so you're going to do this. 2, instead of a, I'm going to write ax, comma ay, minus 3, instead of b, bx, comma by, plus 2, instead of c, cx, comma cy. Okay, so now I'm going to go ahead and combine this into an x and y bracket. Now, the reason I'm leaving so much space is because I can see I've got 3 different components. So for the x, it's going to be 2ax minus 3bx plus 2cx. And for the y, 2ay minus 3by plus 2cy. Okay, so far so good. All we have to do at this point is plug in our numbers. So, plugging them in, ax is 38.9 minus 3, bx is negative 14.8. Be careful with those negative signs. Plus 2 times cx, cx is 0, comma, 2 times ay, 20.7, minus 3 times by, which is 22.0, and plus 2 times cy, which is negative 31.0. Close that bracket off. Okay, simply a math problem at this point. Plug it into your calculator. For your x, you are going to get 122.2. For your y, negative 86.6. So there we have our vector, and just like the previous problem, our next stage is to find the magnitude. Okay, so let's do that. And the magnitude of a vector, it's like Pythagorean theorem. Okay, so we're looking at 2a minus 3b plus 2c, and we're going to put those absolute value symbols around it, is equal to the square root of the sum of the squares of 122.2 squared plus negative 86.6 squared. Let's keep going. So when you calculate that all out, you're going to get 149.77. Now you got to be careful because, again, if you watched video 35, you would have seen that we determined there are 3 sig figs in total. This value here has 5, so we have to adjust this for 3 sig figs. But here's the thing, you cannot just write 149 because technically this 7 rounds the 49 up to a 50. But if you write 150 like this, that's only 2 sig figs, right? These first 2 numbers. So we cannot write this. What we have to do is write it as the following. 1.50 times 10 to the 2. That way the 0 counts. Okay, you cannot just write 150. But because the 0 is after the decimal here, it's significant. Okay, next. So we found the magnitude. Great. There it is. Now let's find the direction. And for the direction, I'm going to do my coordinate axes again. Let's take a look at our values. We had an x value of positive 122.2, a y value of negative 86.6. So I'm thinking we're going to be in the 4th quadrant here, okay? So why don't I go ahead and I'll draw that. Okay. So we got my x, I've got my negative y. 122.2 is my x, and my y is negative 86.6, so a little bit shorter, negative 86.6, and my resultant, here we go, I'm going to draw it in. Tail of the first vector to the tip of the second vector. And my theta, here we go, connecting the hypotenuse to the first vector. Okay, so there's my theta. Now, based on this, you can see that whatever angle I get, whatever I calculate here, it's going to be theta degrees below the positive x-axis. And again, the way we find theta, we use our handy tool of tangent. Tan theta is opposite over adjacent. Okay, so this is the opposite side. That is the y value, 86.6, divided by the adjacent, 122.2. I'm not putting signs. Once again, I explained that in an earlier video. I'm going to figure out the angle and if there needs to be a sign based on the diagram. So I'm not going to put signs positive or negative here. I'm just going to leave it the absolute value. Okay, 86.6 over 122 is 0.70867. So in order to get theta by itself, I take the inverse tangent of that value. Okay. And when you do that, you're going to get theta is equal to 35.3 degrees. And there you go, 3 sig figs. And there we go. Okay, so we can finally quote our answer. So therefore, 2a, let me move that up a bit, 2a minus 3b plus 2c is equal to 1.50 times 10 to the 2, and in brackets, square brackets, 35.3 degrees below positive x-axis. And there you have it. Okay, there is the answer to part B. Hey guys, that's it for this video. If you enjoyed it, be sure to give that like button a click and subscribe to this channel so that you never miss a video from me. Okay? I would also encourage you to click that little bell icon next to the subscribe button so that you get notified every time I post a new video. Thank you guys for watching, and I will catch you later.